Not so long ago, the only widespread use of anti-lock brake systems was on jet aircraft. In the last decade, advances in automotive electronics and growing demands for improved safety features have led to the development of reliable and affordable anti-lock brakes for a wide variety of vehicles. In fact, Buick, always a technology leader, offers anti-lock brake systems, or ABS, as standard or available equipment on virtually all 1991 car lines. It's important to distinguish among the different types of anti-lock systems used by Buick and know how they work. On all ABS-equipped models, brake fluid from the master cylinder is routed through a device which can regulate hydraulic pressure in individual wheel circuits. This hydraulic modulator has no effect on normal braking action. Hydraulic modulator operation is controlled by a small computer, the Electronic Brake Control Module, or EBCM. Some service manuals also refer to this unit as the Electronic Control Unit, or the Anti-Lock Brake Controller. When the car is in motion, the EBCM continuously monitors voltage signals produced by magnetic speed sensors located at each of the car's wheels. A magnetic coil pickup sensor at each front wheel is mounted on the knuckle assembly close to a toothed sensor ring which is pressed onto the outer CV joint. On all front-wheel drive 1991 cars, the rear wheel speed sensor's toothed rings are incorporated in the wheel bearing assembly. A brake switch behind the pedal signals the EBCM when the brakes are applied. If any wheel begins to lock up during braking, the EBCM senses the unequal deceleration rate at that wheel. When this occurs, the EBCM immediately activates the hydraulic modulator, which controls brake pressure to the locking wheel. In all systems, the hydraulic modulator never increases circuit pressure above the master cylinder level produced by the brake pedal. As a car stops, more weight is transferred forward to the front wheels. So during hard stops, the front brakes perform most of the work, while the rear wheel brakes mainly provide stability. For this reason, on all Buick anti-lock systems, the EBCM modulates pressure independently in each of the harder working front brake channels. The rear brakes are modulated jointly as a single channel. This is referred to as three-channel operation. 5 different anti-lock brake systems are used on 1986 to current Buick models. These systems can be broadly classified into 2 types: integral ABS and non-integral ABS. ABS III from Delco Moraine and Tevis Mark II are integral systems. In other words, the anti-lock components are integral parts of the electro-hydraulic power brake system. Fluid from the brake reservoir is pressurized to operating level by an integral electric pump and stored in an accumulator which is also pre-charged with nitrogen gas. The Delco Moraine ABS III system is optional on 1991 and earlier Regal models. The heart of this system is the Delco PowerMaster III, a combination master cylinder, hydraulic booster, and modulator. The PowerMaster III unit incorporates 3 solenoid valve assemblies which are activated only during ABS braking. 2 of the solenoids modulate brake pressure separately in the right and left front wheel circuits. The 3rd solenoid regulates pressure in the rear brake channel. The other integral anti-lock system, Tevis Mark II, appears on 1990 and earlier LeSabre, Park Avenue, Riviera, and Riata models. The Tevis Mark II hydraulic master cylinder and power booster unit produces fluid pressure for both standard and anti-lock brake applications. The valve block, which modulates hydraulic pressure during anti-lock braking, is bolted to the side of the master cylinder unit. The valve block incorporates 6 solenoid valves arranged in 3 pairs. 2 pairs of valves modulate pressure separately in each front wheel brake circuit. The 3rd pair of valves is used for the rear wheel circuit. Each pair of solenoids contains an inlet and an outlet valve. The inlet valve is normally open, while the outlet valve remains closed. During ABS operation, the EBCM reduces brake pressure to a locking wheel by closing the inlet valve and opening the outlet valve. To hold brake pressure constant, the EBCM closes both valves, isolating the wheel circuit from the master cylinder. To increase pressure and apply braking, the EBCM returns the inlet valve and outlet valve to their normal positions, allowing fluid to flow directly from the master cylinder to the wheel brake. The 3 anti-lock systems introduced on 1991 cars are all non-integral types. Hydraulic pressure for anti-lock and non-anti-lock braking is provided by a conventional master cylinder and vacuum booster. This is the Bosch ABS VI anti-lock system, which is standard on 91 Riviera and Reata. As in other non-integral systems, the Bosch ABS routes brake fluid from the master cylinder through a separate hydraulic modulator unit. The Bosch hydraulic modulator incorporates 3 solenoid valves, 1 valve for each of the 3 brake channels. The EBCM can command each valve to any of 3 positions: releasing brake pressure, holding brake pressure steady, or increasing pressure to the affected wheel brake. The Bosch hydraulic modulator also incorporates a pump motor, which runs constantly during ABS operation to recirculate brake fluid to the master cylinder. Pump hydraulic pressure is not applied to the wheel circuits. The solenoid valve relay and pump motor relay are located beneath a removable cover on the hydraulic modulator. The modulator pump assembly is serviced as a complete unit. Only the relays are replaced separately. The Roadmaster wagon is equipped with essentially the same Bosch ABS VI system as Riviera and Reata. However, since the wagon is a rear-wheel drive vehicle, there are some differences. The Roadmaster system uses a single combination valve to proportion hydraulic pressure between the separate front and rear circuits. The speed sensor for the rear wheels is located in the rear axle differential assembly. A toothed sensor ring is pressed onto the axle drive pinion. If either rear wheel begins to lose traction, the speed change is immediately transmitted to the brake controller by the drive pinion sensor. Tevis Mark IV ABS is standard on the 91 Park Avenue and optional on LeSabre models. Brake fluid from the diagonally split Tevis master cylinder is routed through a remote pressure modulator valve unit which is mounted on the car's front frame. The Tevis Mark IV hydraulic modulator unit also incorporates a pump and a small brake fluid reservoir. When the brake pedal is depressed beyond approximately 40% of its total travel limit, the EBCM receives a signal from the combination anti-lock torque converter clutch switch mounted behind the brake pedal. When received during ABS operation, this signal activates the pump motor. Fluid from the small reservoir is then pumped into the master cylinder circuit. The pump continues to run until the brake pedal is raised sufficiently to open the switch. The Tevis Mark IV hydraulic modulator valve unit incorporates separate inlet valves and outlet valves for each of the 4 wheel circuits. The valves modulate pressure in the 3 channels exactly as in the Tevis Mark II system. The 2 separate pairs of valves for the rear wheel circuits are operated jointly as a single channel. The Tevis Mark IV hydraulic modulator unit, including the pump motor, is serviced as a complete assembly. Only the reservoir is replaced separately. The third non-integral system is the Delco Moraine New Departure Hyatt ABS VI, available as an option on the 1991 Skylark Grand Sport. The ABS VI hydraulic modulator assembly is bolted directly to the Delco compact master cylinder. ABS VI uses a unique method of modulating pressure during anti-lock braking. Instead of the solenoid valves, 4 small pistons are used to control hydraulic pressures in the 3 channels. The pistons are moved by ball screw mechanisms which are gear-driven by 3 bidirectional DC electric motors. The motors are contained in a motor pack which can be detached from the hydraulic modulator. 2 of the motors drive the pistons for the front wheel brake circuits. The third motor jointly operates the 2 rear brake pistons. When ABS VI is inactive, the 2 front brake motor shafts are held by powerful electromagnetic disc brakes. A simpler expansion spring brake holds the motor shaft for the rear brake pistons. The motor shaft brakes normally hold the pistons at the top of the chambers, so during non-ABS braking, fluid flows directly from the master cylinder to the brakes. During ABS operation, the EBCM controls current supply to the electric motors and uses the pistons to regulate the volume and pressure of brake fluid in each channel. 2 solenoid valve assemblies isolate fluid pressure for independent modulation of each of the front brakes. The hydraulic modulator and the motor pack are serviced separately by unit exchange. Replacement ABS VI solenoid valve assemblies are available in a service kit. All Buick Antilock Brake Systems feature built-in self-diagnostic capabilities. The electronic brake control module, in addition to controlling the system, monitors and tests various parts of the ABS for correct operation. When the EBCM detects an error, it can interrupt ABS operation, set diagnostic trouble codes, and illuminate an anti-lock warning lamp in the instrument panel. When verifying an ABS-related complaint, the anti-lock warning lamp should be checked by turning the ignition switch to the run position. Under normal conditions, with the ignition at run, the anti-lock lamp should light, then turn off after 2 to 4 seconds. The anti-lock warning lamp remains lit continuously to indicate that the EBCM is currently detecting an ABS fault and is not permitting anti-lock functions. If the red brake warning lamp also remains on after the car has started and the parking brake is fully released, the lamp could indicate a problem affecting the base brake system. This condition should be corrected before continuing anti-lock diagnosis. On cars equipped with ABS III or ABS VI, the anti-lock lamp may also flash on and off. This indicates the EBCM is currently detecting a fault, but ABS functions are still available. With the exception of the Tevis Mark II ABS, EBCM trouble codes and other diagnostic functions can be accessed using the T100 or Tech 1. However, for a full understanding of each system, complete with special handling precautions, schematics, and comprehensive diagnostic information, there's no substitute for the Buick Service or Electrical Systems Manual. Several diagnostic displays are available when using the T100 or Tech 1 scan tool. When diagnosing 1991 cars, the Tech 1 should be fitted with the GM 88 to 91 brake cartridge. Also, special AL-DL adapters are required to enable both the T100 and Tech 1 to communicate with the Bosch anti-lock systems. ABS III and ABS VI have the widest range of self-diagnostic capabilities, a total of 58 possible codes. Both systems display a current data list and up to 5 diagnostic codes in the order they occurred. Codes are also identified as current or history codes. ABS III and ABS VI displays also incorporate a code history feature, which indicates how often the code set occurred over a given number of ignition cycles. An ignition cycle occurs each time the vehicle is started and driven faster than 10 miles per hour. The code history function also displays data that was present when the last code was set, information which may prove useful in recreating the cause of an intermittent problem. Bosch ABS IIu displays up to 3 stored trouble codes. Wheel speed sensor and brake switch data are also provided in the data list. The Bosch ABS also has a code history function, which indicates the number of ignition cycles that have elapsed since the code set. A 0 cycles reading indicates the code is currently present. The Bosch code history information includes data on vehicle speed, brake switch position, and ABS status when a code was set. The Tevis Mark IV ABS also displays a data list and trouble codes, but does not provide code history information. The Tevis Mark II ABS does not communicate with T100 or the Tech 1 scan tool. However, on 1988 to 1990 Riviera and Riata, and 1989 to 1990 Electra Park Avenue and LeSabre, the anti-lock warning lamp can be used to read flash diagnostic codes. Flash diagnostic codes are accessed only by connecting a jumper tool or wire between the appropriate terminals of the AL-DL connector. With the jumper connected, the ignition switch is turned to the run position. If the warning lamp illuminates, then turns off for approximately 3 seconds, and then begins flashing, a trouble code is being displayed. After flashing a code, the warning lamp remains lit steadily. However, a total of 7 codes may be stored in the EBCM, and each must be read separately. To display any remaining codes, the ignition should be left in run while the jumper is removed, then replaced. This step is repeated until the lamp no longer flashes when the jumper is reconnected. If a car equipped with Tevis Mark II ABS has not been started for several hours, both the anti-lock warning lamp and the brake warning lamp may remain on. This may be caused by normal pressure leak down in the hydraulic accumulator. If this is the case, the lamps remain on for up to 30 seconds while the pump runs to recharge the system. In the course of diagnosing Tevis Mark IV ABS, a special pinout box must be used to measure for continuity, voltage, and resistance values between various terminals on the EBCM connector. A different pinout box is required for Bosch ABS and Tevis Mark II diagnosis. The T100 and Tech 1 can be used to perform various ABS component tests. Tests vary with each of the systems. The service manual diagnostic procedures indicate when and what tests should be performed. When a complaint is received for which no current diagnostic codes are present, or when a problem is intermittent, the car should be driven in an attempt to recreate the condition. During the test drive, the Tech 1 can be used to monitor the data list parameters on all 1991 systems. It should be remembered, on Bosch and Tevis systems, anti-lock functions are disabled when the diagnosis mode is entered. ABS self-diagnostic abilities, combined with proper use of the Buick service manual and the T100 and Tech 1, should enable you to resolve most ABS complaints.